Hello, we're going to give a few basic, really basic baby steps on a field of mathematics that is fascinating for many, and that has to do with the complex numbers. I thought that perhaps I can give you some supplementary information. Um, this is a set of numbers that is a big deal in mathematics. You can refer here to some information that is listed on towards the end of the book, and specifically you go to the part that's called preliminaries, and under preliminaries you want to really read very well this section on complex number operations. That's what the section is called. Um, so this set of numbers is a big deal because it completes the real numbers. And this is a whole subject on its own. So I just wanted to motivate with something very accessible, very simple, so that we are all on the same page. So complex numbers are um, defined according to this equation. We use the letter I to denote. This is the basic unit in complex numbers. I is the square root of -1. This makes has it's a kind of quantity that makes wonders. It allows to have solutions for equations that in the set of real numbers would not have solution. And so when we define I equals square root of -1, the equivalent um, thing is to know or to use that that implies that I square is -1. And there is a whole family of algebra and algebraic tools that will carry in very much the same way as we do algebra with other objects. But I just would like to point out that there are some nice properties of these numbers. First, we are going to refer to a complex number as something that lives in a plane. So just as if we were, um, I guess the symbol here is something that looks like the letter C. Okay, this would be denoting the set of complex numbers. But you want to keep in mind that this reminds you or looks a lot like R2. Okay. In particular, because this is a plane, and so now the horizontal axis is something we're going to refer as the real axis, and the vertical axis is something that we are going to refer as the imaginary axis. So we use this notation for the vertical axis and the horizontal axis, respectively. So let's talk about locating a number here in this plane. And in general, we would refer to a number in the plane using its coordinates. Okay, so perhaps you have very good eye here, very good resolution, but let's talk about a number that is located in this part of the plane. Okay, so I'm drawing here, um, kind of sketching something. So this number is going to have a coordinate on the horizontal axis, and then is going to also have a coordinate on the vertical axis. Okay, and so in general, we would say, well, not in general, but um, in this specific case, this number has coordinates 5 on the horizontal axis and 2 on the vertical axis. And so this is, if we were in R2, we would write something like 5 comma 2, and we would write this between parentheses. But we are in the complex plane, so even though we're describing two coordinates, we are going to write this as a summation, as a sum, and so we always write the real part first, which is the first coordinate. So we say 5 plus, and then we write the vertical coordinate and multiply that. We write that as a coefficient of I. Okay, so we write here 2I. Okay, So this is how we would denote this number in the complex plane that has, now we can say that this is called, I don't know, z, okay? And the important thing is that we can say, well, if that is z, we can then say the real part of that number, the real part of z, is equal to that first coordinate 5, and the imaginary part of z, okay, in this case would be equal to 2.